All right, seventh grade students, you made it through Unit 1. We are moving on to Unit 2. In Unit 2, we're going to start by talking about comparing and ordering integers. We'll also talk about the coordinate plane in Unit 2 before we move on to integer operations. So, I apologize in advance for these notes. Some of these numbers and number lines I have to draw with a pencil, so it's not going to show up too well on the screen. You should be able to read it pretty well on your note page. So the first thing, I just have a sample number line up here with 0 in the middle, and just a quick reminder, the positive numbers are the ones here on the right, and our negative numbers are going to be the ones here on the left. So probably review, but just to make sure we know. So positive numbers are on the right of 0, negative numbers are on the left of 0. So as you scroll, or as you look down, it says graph the integers on a number line, then write the numbers in order from least to greatest. So we have our list of numbers for the first one. I've already drawn the number line and put numbers on there for you. If you notice, I go by 2s. So for some of you, I have to put them in between integers. So our first one that we need to put on here is negative 14. So negative 14 is going to be right here. Then we have negative 11, which would be between negative 10 and negative 12. We have negative 13, which is going to be between negative 14 and negative 12. We have negative 9, which is going to be between negative 8 and negative 10. We have negative 20, which is going to be right here on the negative 20. And then we have negative 7, which is going to be between the negative 6 and the negative 4. So the first thing we want to do is put them on the number line, and then we want to put them in order from least to greatest. Now this is pretty simple after we put them on the number line, because we just go from the left to the right. So that means negative 20 would be the smallest number, and then we'd work our way up. Negative 14, negative 13, negative 11, negative 9, negative 7. The important thing to notice is that when we deal with negative numbers, the bigger digits are actually smaller numbers. So 20 is bigger than 14, but when they're negative, 20 is actually smaller than 14. I'm going to let you guys go ahead and do number 2. To be honest with you, I drew the number line and mislabeled it, so you're going to need to add on some numbers to the right. I didn't text the 25 and 35, so you might need to add some numbers on over there. All right, moving on to your notes, the next thing we're going to talk about is absolute values and opposites. So I wrote down a couple definitions for you. Absolute value is a number's distance from 0 on a number line, and opposites have the same absolute value but have different signs. So let's look at a couple of examples. So if you were to label this number line, so let's say I have 0, negative 1, negative 2, negative 3, 1, 2, 3. So if I gave you the number negative 2, okay, its absolute value would be its distance from 0. We show absolute value by putting bars around it. So the distance from 0 is 2. There's no such thing as a negative distance. So even though it's a negative number, when you take the absolute value, it's going to be positive 2. Now if I took the absolute value of a number like 30, it would just be 3, because that's 3 away from 0. Now we're talking about opposites, we're talking about two numbers with the same absolute value. So say that I have a number line. Let's say I have 10 and negative 10. These would be opposites because they're both a distance of 10 away from 0. Okay, same thing if I had 3 and negative 3, 4 and negative 4. Those are opposites because they have the same distance from 0. So let's practice this a little bit. It says to state the absolute value of the number. So the absolute value of 1 is just going to be 1 because it's 1 away from 0. The absolute value of negative 9 is 9 because it's 9 away from 0. The absolute value of 15 is 15. And the absolute value of negative 12 is 12. So again, notice that all absolute values are positive. So the next one says to state the opposite of the number. So if I have a positive 14, the opposite would be negative 14. The opposite of negative 33 is positive 33. The opposite of negative 24 is positive 24. And the opposite of 81 is negative 81. The next section says to complete a statement using less than or greater than. So the first one is less than, the second one is greater than. Okay. A thing to remember, the way I like to remember it is they kind of look like Pac-Man symbols, and you always want to eat the bigger number. Okay. So For the first one, we have negative 11 and negative 9. Now, even though 11 is bigger than 9, we're working with two negatives. So negative 9 is going to be greater. So I'm going to keep negative 9. So I would read this, negative 11 is less than negative 9. For number 2, I have 1 and negative 5. If you have a positive and a negative, positive number is always going to be bigger. So this would read 1 is greater than negative 5. For number 3, we have 4 and the absolute value of negative 15. We need to start by finding the absolute value of 15, which would be positive 15. And 15 is greater than 4. If you look at the back page, the first thing we're going to work on is evaluating each expression. So remember, that means to basically get the answer. So for the first one, we have the absolute value of negative 32 plus the absolute value of negative 6. So let's start by finding the absolute values. So that would be 32 and 6. And then we're just going to add those together. So we'll get 38. For number 2, it's a little bit harder. We have negative absolute value of negative 7 plus 12. So the front negative is going to go out there. And then the absolute value of negative 7 is 7 plus the absolute value of 12 is 12. So when I add those together, I'm going to get positive 5. I'm going to let you guys try number 3. Make sure you do that on your own and then check it with the answer key. Looking down a little bit further, it says evaluate each expression when x equals negative 7. So we're still evaluating. It's just that we have to plug in a number for x. So we're going to start by rewriting it. So I have the absolute value of negative 7. Okay, I already had a negative, and then x is negative 7. So negative 7 is positive 7, and then the absolute value of positive 7 is 7. For number 2, I'm going to have the absolute value of negative 7 plus 5. The absolute value of negative 7 is positive 7 plus 5 is 12. I'm going to let you guys do 3 and 4. Need any help? Make sure you ask in class. And then for the next section, we're evaluating expressions still. And now we have 3 different variables. We have x equals negative 3, y equals 4, and z equals 2. I'm going to let you guys do number 1. I'm actually going to walk you through number 2 because there's so much going on. So first thing, I'm going to keep my absolute value marks. I'm going to write 4. I'm going to replace y with 4 and z with 2. Then I'm going to subtract, and that's 3. Let's plug in a negative 3 for x. So absolute values are a form of grouping symbols. So I'm going to do all my work first. 4 times 4 is 16 times 2 is 32. And then I have 3 times absolute value of negative 3 is 3. The absolute value of 32 is 32 minus 3 times 3 is 9. So I'll wind up with 23 from minus 3. Alright, the questions at the bottom are your review questions for this section, so of course you are in charge of those. Make sure you get all the notes completed, and you can check them in class.